Did you get x plus 7, x minus 7 for the first one? And x plus 7, x plus 7 for the second one. So now, we look at our denominators, we look at the factors, and we say, what's missing? In the first one, we're missing another x plus 7. In the second one, we're missing another x minus 7. So now we have a common denominator of x plus 7, x plus 7, and x minus 7. On the top, we're going to have 7x plus 49 plus 3x minus 21. Do we have any like terms? Yes, we do. So if we combine our like terms, we get 10x plus 28. Now sometimes what's going to happen is you're going to simplify things, and it could be that something simplifies away. So in order to check that, you'll want to factor the top completely when you're done. Can I factor the top at all? Yes, I can take out a 2. And now I check, after I factored the top completely, is there any factors that are identical? In this case, no. If there was, then we could simplify it further. But this would be as far as we could go. So the annoying thing about adding and subtracting in this case is look how many times I had to rewrite the denominator. Some of you are going to be tempted to say, oh, I'm not going to write the denominator. I'm just going to work on the top and forget about the bottom because I don't want to write all that stuff. Okay? If you decide to do that, you do lose some marks for showing your work along the way. No, you have to write it out as you go. The little two little ticky mark thingies, no. All right, so here is our next one. Again, I'll give you a head start for factoring. To get 18, it's got to be 6 and 3. The 6 is positive, the 3 is negative. Yes? And here, we're going to have plus 5 and minus 4. So everything is missing everything. That is true. However, there is something that you can see before we keep going. Because you might be tempted, right? You might be tempted in this first one here. Oh, yes. Can you see that you can get rid of those early? Because they're the exact same factor. No, that would, if I were to rewrite it, I have 1 over n plus 6 minus n minus 2, n plus 5, n minus 4. If you don't see that step, that you could simplify it early, you will make this question into a horrendous simplifying disaster. So if you don't recognize at this step, oh, those n minus 3's are the same, I can simplify those, this question turns out really, really nasty. Okay? So be aware of that. If you can simplify something, simplify it. And you can only simplify things if the factors are identical, like they are in this case. Because now, the only thing that I'm missing in the second one is n plus 6 and n plus 6. I am still missing n plus 5 and n minus 4 in the first one. So now we have one common denominator, n plus 5, n minus 4, n plus 6. Up here, if I multiply this out, I'm going to get n squared plus n minus 20. I'm just going to hold that in brackets for right now. Then we're going to subtract. And because of that subtracting sign, if I multiply these out, I have to keep them in brackets because we're subtracting all of it. So we're going to get n squared plus 4n minus 12. Now when I combine those like terms, n squared minus n squared, that's going to go away 0. If I have n minus 4n, I'm going to get negative 3n. And if I have negative 20 minus negative 12, I'll be left with negative 8. All over n plus 5, n minus 4, n minus 6. Yeah. You know when to do that whenever you have one factor in one place that's x plus 7, but in the other place it's exactly the same but written, oh sorry, x minus 7 in one place, and it's exactly the same but reversed in the other place, then you know to factor out that negative. This can't be factored any further, so this is as simplified as it gets. Questions you can do now? Six, 7, 10, 12, and 13.